Hello, I'm Wong Xianjun from RK84 Product Design Engineering, Faculty of Mechanical Engineering Technology. Today, I would like to present about my final year project 1 entitled Investigation of Banana Trunk as Blast Protection Wall. Before we go any further, let us look at some of the key words. First, explosion. A violent shattering or blowing apart of something which could be caused by several factors such as industrial accidents, bombs, but what we focus will be UXO. This leads us to the second keyword, unexploded ordnance. It is ammunition which has been fired but has not functioned as designed and can be particularly dangerous because all the normal safety features have been overcome. It includes Navy sea mines, Army hand grenades, Air Force rockets, but what we will be focusing is the land UXO. Third, banana trunk fiber. Scientifically, it is also called as pseudostem fiber. The part of the banana plant that looks like a trunk is the pseudostem. It is formed by overlapping leaf shapes that are tightly packed. Although the pseudostem is quite fleshy, which mainly comprises of water, it is quite strong and can support a group weighing up to 50 kilograms or more than that. Last but not least, we have blast protection, or in our case, could be also called as blast mitigation. An individual structure which is often used to provide a standoff area for the protection of critical structures from an explosion. By wave reflection and interaction with the safety wall, it acts as a barrier to the transmission of blast waves. Based on the current blast mitigation, sandbags usually used as blast mitigator in military open field explosion tests. In the scientific literature, no record of primary blast evaluation on banana trunk was found for this study. Since for those previous normal blast mitigation, sandbags were being used, the fragmentation of stone and sand in the bags is potential splinter. Hence, in this project, it is hoped that the juicy and fiber layers of the banana trunk could help in handling this main problem. Another challenge is that the sandbags used are usually heavy. When a number of small UXO have to be dealt urgently, it is usually to provide each UXO item with a 32 bags surrounded. This is according to the SOP laid out by the Special Actions Unit of Royal Malaysia Police. Therefore, it is quite challenging and exhausting to bring these sandbags manually to UXO location, especially those in the middle of the jungle where the transportation is not reachable. By using banana fiber, it is easy to be carried, no matter by transportation or by human energy. In fact, banana trunk is less risky than the heavy sandbags because when it is being put near the UXO item, the vibration generated by putting down the heavy sandbags might trigger the UXO item to explode before the men have time to leave the location. The main objective of our research is to investigate the visibilities or the characteristics of banana trunk as an alternative option for sandbags being blast protection walls for UXO. These previous related studies performed until now did not consider mass as a variable. Hence, in this research, banana trunk will be studied as a light mass mitigator. In addition, using readily available natural materials, which in our case is banana trunk, the cost of setting up blast protection wall could be greatly reduced. In our research, the banana trunk amount used is not more than 3 banana trunk per time usage. Next, the standoff distance from the blast exploding point is around 20 meters, applied by SOP of the Special Actions Unit of Royal Malaysian Police. Meanwhile, the analysis of the properties of banana trunk fiber will be done through FEA, STM for tension testing, DIC, as well as the PSD test. Finally, the Amulex which being used as UXO explosion simulation will be weighted at 500 grams as normal packaging weight average. So, through this FYP research, it will show us the potential of banana trunk to be used in blast mitigation, since the fluid and fiber net in the trunk could slow down the splinter of an explosion. Due to banana pseudo trunk fibers' biodegradable capability, it is hence labeled as eco-friendly. In fact, banana trunk fiber is a kind of natural fiber, possesses certain good characteristics. Besides, banana is the second most widely cultivated fruit in Malaysia, covering approximately 530,000 metric tons of overall production, accounted of almost 24% of Malaysia's total fruit production that year. So if banana trunk is successfully to be used as an alternative option for sandbags in blast protection, this could obviously increase the side incomes of banana plantation farmers. The question is, does banana trunk really could be used as blast protection wall? This is what made our research FYP so important, because this research will definitely fill up the research gap that rarely or almost none of the previous researchers conducted on this specified field. Now, how could this research be conducted? Well, before going any further, we need to know one of the very important elements, which is Amulex, the emulsion explosive used in explosion test. It is usually used for general surface blast and is added with aluminium to provide higher explosive energy. Or, of course, its price is much more cheaper than TNT, C4, and even PE. Now, after the banana trunk is harvested manually, it will have to go through field blast test. If we look at this illustration of our explosive materials, the Amulex is being wrapped and molded into a ball shape, and several ball bearings will be stick around the Amulex ball before it is wrapped up by a plastic sheet. So after having this Amulex ball representing UXO, we will dig up such underground hole just beside the UXO or the Amulex ball. In the middle of the hole, 3 banana trunks will be piled up horizontally, and a piece of aluminium coil being put at the end of the stacked trunks vertically. And now, the whole setup is ready to be run. There are several methods used for banana trunk fragment analysis. First is the SEM analysis. After field blast tests being conducted, the surface microstructure of our banana trunk fragment specimen will be observed using such tabletop microscope. The specimens will be scanned based on 3 levels of magnification to observe the binding element of specimen's boundary and the pattern of the structure. The next method used is via the high power microscope to see the microstructure of the banana fiber fragments after undergone blast test. The fragmented banana fiber will be placed on the stage, and normally the lowest magnification of 5 times will be standard. So, to wrap it up, this is a rough picture of our FYP1. Due to my video time constraints, if you would like to know more about the research, please do check out for my thesis. Thank you for watching the video. See you and have a nice day.